Hello friends, welcome to Prismatics online class. In this class, we are going to look at the topic on the board, complex number. And what is a complex number? From our previous class, we defined complex number as what? Summation of what? Real parts denoted by Z and the word pure imaginary denoted by MZ. But today, we are going to look at the what? The concept of what? Conjugate. The conjugate of what? Complex number. The complex number x plus iy and x minus iy are called conjugates of complex number. If complex number z is equal to x plus iy, its conjugate is denoted by what? Z bar, or some textbooks say Z prime. So anyone, but this one says Z bar. So Z bar is equal to what? X minus what? Iy. Okay, now in solving these questions, what do we going to do? We are going to look at this. If complex number z is equals to Z bar, this is complex number. This is the conjugate of the complex number. So that is how to know them. Or sometimes we write z is equal to z prime. They are the same thing. So the conjugate of this complex number is z prime. So if they give us something like 3 minus 5i, the conjugate will be 3 plus what? 5i. So the process of changing the negative sign to positive, or changing positive to what? Negative sign, is called what? The conjugate. So only thing that you have to do here is just, if the binary operation is in negative, you change it to positive. If it is in positive, you change it to negative. That is all about conjugate of complex number. Okay. So now let's look at this question on the example. If z is equals to this, its conjugate is denoted by what? Z bar equal to what? 3 plus what? 5i. And that is how to know it. So the complex number is equal to 3 minus 5i. Its conjugate is equal to what? 3 plus what? 5i. So the conjugate of the complex number here, 3 minus 5i, the conjugate is what? 3 plus what? 5i. But if they give you 3 plus 5i and ask you to find the conjugate, the conjugate of it is what? 3 minus what? 5i. Okay. Now question on the board. Given that z is equal to x plus iy and z bar equals to x minus iy, express each of the following in terms of what? X and y. A, z plus z bar. B, z minus z bar. C, z into z bar. D, z square. E, x minus z, x minus z bar. F, x plus z, x plus z bar. Now we are going to take them one after the other to solve them and prove the solution. Okay, solution. Solution A. How do we do? That says z plus z bar. Now our z is equal to x plus I, x plus iy, bracket in plus, this is addition, plus what? X minus iy. So how do we add this? We are going to add real part to real part and imaginary to imaginary. So now what do we have? X plus what? X into plus iy minus iy. Now s to s will give us what? 2x. I to I will give us what? Plus what? 0. Because you own somebody, you have iy minus iy to turn to 0. So finally your answer is what? 2x. In other words, what does it mean? The implication of this means that if you add complex number with its conjugate, you are going to produce what? Real part. So there does not exist imaginary. when you add complex number with its conjugate, you only produce the real part, but there does not exist the what? The imaginary. That is the implication of it. So you only produce this thing. In other words, this is in form of 2s plus 0I. So that is it. Okay, solution B. Now let's solve solution B. We have solution B that says z minus z bar. They have given us that z is equal to x plus iy minus x minus iy. So how do we do this? S minus x, real part to real part, s minus x plus plus this times this. You remember that this will multiply this. That is the reason why we say s minus x. So this one now, I y minus I y. So we are going to have here 0 plus minus minus we turn to plus. We have I y plus I y, which will give us now 0 plus 2 iy. Finally, we have it as of 0 iy. So what is the implication of this? Implication of this is that whenever you subtract complex number from its conjugate, that you are going to produce what? You are going to produce what? Imaginary, pure imaginary. So in other words, there does not exist what? Real part. So you only produce what? Imaginary. And that is things now. So the real part of it is what? 0. But when you add complex number with its conjugate, you produce what? The real part. And the imaginary side will be what? 0. So that is the implication. I hope you understand it. Okay, thank you. Now are you through with here? Okay, let's complete the solution. Okay. Solution C. See, they say z multiplied by z bar. Now we have that x plus iy multiplied by x minus iy. Now how do we do this? X into s minus iy into plus iy into s minus iy. X times this, we have it x squared. S times this, we have it as well x iy. Iy times x, we still have it as plus x iy. Iy times this, we still have it as minus iy, I square, y square. Now, by cancellation law, this and this will cancel out. This and this will cancel out. We will now have that x square minus, and always recall that I square is equal to minus 1. So from here we have that this is minus into minus 1 y square, which minus minus will give us what? Plus x square plus what? Y square. So whenever you multiply a complex number with its conjugate, you produce what? Real part. There does not exist what? The imaginary. The imaginary is always what? 0. Whenever you multiply a complex number with its conjugate, that is the implication. Okay. Now let's solve for solution D. We say they say z square. Z square means x plus iy all square, which means what? X, which implies x plus iy into x plus iy. That is x into x plus iy into what? Iy into x plus iy. S times this will give us what? X square. S times this will give us what? Plus what? X I y plus x I y plus I square what? Y square. Okay, if we collect like terms, we have that x squared plus 2iy minus what? Minus, okay, plus into minus 1 y squared. Always remember that I square is equal to what? Minus 1 in complex number. Finally, we have the x squared plus 2iy minus y squared, which will give us what? X squared y squared plus 2iy squared. And that is the answer. That is how to do it. Okay, thank you. Now let's look at solution E. Let's look at solution E. I hope you have you are through with this. Thank you. Okay. Now let's look at solution E. Solution E, we have x minus z into x minus z bar. Now this is the same thing as saying x minus into bracket, as z is what? X plus iy, close it. That is with the big bracket. Into, with another one, x minus into x minus x minus iy, close it. Okay, now how do we do this? Expand inside the bracket, which is x minus times this will give us minus x, minus times this will give us minus iy, close the bracket, into what? X minus times this, we have it as minus, minus times this, minus times this, okay, minus times this, have it as minus, minus times this, have it as what? Plus x, minus times this, we have it as plus iy. Now, what do we do? And how do we do this? What do we do here? Okay, look at the where we made mistake. Now let's continue here. So the x minus into x plus iy, close it with a very big bracket. Now into also x minus iy. Now let's go. X minus x, minus times this will give us minus iy, close the bracket. Okay, into x, this minus x to this plus iy, close it. What do we do? X minus x will give us what? Will give us what? 0. 0 minus iy, close the bracket, into x minus x will still give us 0 plus iy, close it. Now what do we have here? We have this as iy into what? Into iy, close it. Now minus times this will give us minus I square y square. Record, always record that I square is equal to minus 1. Therefore, what do we have here? We have that minus into minus 1 y square. Minus times minus will give us what? y square. So that is it. So y square is what? The answer to the solution to the problem. Thank you. And that is how to solve it. I hope you are through. Did you understand it? So that is how to solve the problem and prove it. So we are going to have this as their answer. Okay, now let's finish it up. Now we have another solution, solution F. Solution F, where we have x plus z. In fact, take solution F as assignment. Go try it. Just substitute z here. Substitute what z by here. Multiply it and get your answer. Now let me give you another question like this. When we have something like given that z equals to 3 plus I equals to 3 plus 4I, and z bar equals to 2 equals to 3 minus 4I. Now let's look at z plus z bar. What does it mean? This means 3 plus 4I equal plus 3 minus 4I. How do we add them? 3 to 3, we have 3 plus 3. Now, plus 4I minus 4I. Finally, what do we have? We have this is 6 plus what? 0I. So whenever you add complex number with its conjugate, you get what? You get what? Number. You get the real part, but the imaginary will be what? 0. The same thing that when you multiply, when you add, subtract, assuming we have z minus z bar. What do we have here? We will now have 3 plus 4I minus what? 3 minus 4I. What do we do? 3 minus 3 plus 4I minus 4I, which will give us 0 plus what? 4I plus 4I. Finally, will give us 0 plus what? 8I. So whenever you multiply, whenever you add complex number with its conjugate, the real part does not exist. Why the real part? The imaginary part exists. Likewise, multiplication. Try the multiplication, multiply them and check and know what is your answer. So that is how to solve all this complex number. Whenever you talk of what? Conjugate, complex conjugate, and that is how to do it. Thank you and God bless you. Remember to subscribe to my YouTube channel, Prismatis Online Class. Bye.